we're going to look at problem number 14.1 in the textbook. This is about the pharmaceutical industry. We have 21 firms and 12 financial measurements for each of the firms, 9 of which are qualitative variables, and we're going to use those to cluster the firms. And you can see here are the firms and the different variables that we have. So we're asked to decide the best way to cluster these things. So the first thing we're going to do is come over here to Analyze, and we're going to go to Variable Methods and then Cluster. We're going to put all of the quantitative variables in here, and they're Y's, and we're going to start with hierarchical, and we're going to use single linkage, and we say OK. And the dendrogram we get back shows us a high degree of chaining. In other words, we have these three that form a cluster, and then the next cluster forms by adding one more observation, and then another observation, and another observation. We kind of go along in that manner. And that's something that we actually want to avoid, because if I wanted to say, well, give me the two best clusters, it would be everything here except for this number 6, or the top 3 clusters. If I had to get 3 clusters, I would have everything but 8, which would be a singleton, and 6, which would be a singleton. So that's not the best clustering we can do with. So let's come here and run it again. We'll try it with a different one of these linkages. Let's try the average linkage this time. And we see here it looks a little bit better, although you might see a little bit of chain behavior going on here still. But we could reasonably say, well, 2 groups, that would be if we were to cut right between here and here. So that would give us 3 in one group and everything else, all these others, in another group. So average doesn't actually look like it gives us that good of grouping. If we were to go down to, say, 1, 2, 3 groups, that might be a little bit better, or 4 groups even. But if we went to 4 groups, then 8 would be all by itself. If we went to 5 groups, 6 and 8 would both be all by themselves. So let's try complete linkage. Cluster, let's recall this, and we'll put that on complete linkage there, and we'll say OK. And when we do complete linkage, we start to see what looks to be even better. If we had 2 groups, so we were to cut this here, we would have about half the data, half of the observations in this top group, the other half down here. If we had 3, we'd be cutting it here. So we would have this group here, these 3 together, and then this one. That actually looks a little bit better than what we've seen so far. So let's do one more where we look at Ward's method. Recall that, click on Ward's, and say OK. So with Ward's method, we get what appears to be the best clustering, and if we had 2 groups, we would have very similar to what we had, I guess, with the last one that we just looked at, and 3 groups would also be similar as well. So we're going to say, let's look at 2 groups, 3, and 4 groups, and those are, or maybe even 5. Those are kind of the best number of clusters that we might possibly want to fit this data to. So we're going to go over now and look at k-means. So we go back to Analyze, Multivariate Cluster, Recall. That puts all of the right quantitative variables up here. And now, instead of doing hierarchical, we're going to do k-means. And we're going to say OK. And it's going to say what number of clusters do you want to consider. And we made the argument that anywhere between 2 and 5 is going to be what we want here. And so then we're going to say OK, go, and we get this output. So you can see for k equals 2, we have this cluster. So cluster number 1 has 11 elements, cluster number 2 has 10 elements, and then we get summaries of the clusters by looking at the average for all the different variables. So market cap in cluster 1 is an average of 97. Market cap in cluster 2 has an average of 14. Beta 0.43 for cluster 1, 0.62 for cluster 2. Price to earnings ratio is lower for the first cluster than the second. Return on equity 35 versus 14. Return on assets 14 versus 5. Turnovers are fairly similar. Leverage are a little more different, and so forth. So I look at these clusters and the averages and say, which, can I come up with a story? What kind of describes cluster number 1? And it looks like it's high market cap, lower beta, low price to earnings, high return on equity, higher return on assets, and so forth. And cluster 2 would be low market cap, higher beta, although these aren't really that different from each other, high price to earnings ratio, low return on equity. And we could go through each of these different clusterings, k-means clustering, and do the same sort of thing with 3 clusters. We have still cluster number 1 with 11, and that's the same 11 that we have up here. We know that because the means for these different variables are the same. But then we're breaking the other cluster into 2, one with 3 and one with 7 observations, and we can see that we have 23.37 is the average market cap for the 3 in group 2, cluster 2, and 10.3. So is there a story? We got high market cap, medium market cap, and low market cap. Betas here are essentially the same for the first 2 clusters, and then we get a high beta for the 3rd cluster. Price to earnings, the first and third are very similar. In the middle, we have a much higher price to earnings ratio, and so you can go through and see how these things differ based on that. And that's really going to be the story that we're looking for. If we have 4, we again have these different values for each of the variables in the respective clusters, and we see the same thing with cluster number 5. So which of these clusters best describes the data set? There's something called the cluster comparison criteria, and this is something that's calculated for you for free whenever you do k-means clustering. And it looks like here they're saying that 2 is the best cluster of all these. So this CCC number should be as big as possible, and that will give us the optimal clustering number of clusters. But just because you see this optimal CCC as given in the output and jump doesn't necessarily mean that's the best clustering that you could use. In other words, if you were to ask experts their opinion, they might come in here and say, yeah, really you should. And you could look at the components of this second cluster when you go from 2 to 3. Should these things really be separated out or not? And you could do the same sort of analysis based on any of these different numbers of clusters. So just because I'm saying 2 is the best here doesn't necessarily mean that's the one you would want to go with, even though we do have this number that is suggesting that one is the best. So in other words, refer to or defer to those with expert information or experience, domain knowledge in situations such as this. A very good way to see what's going on with these means is to look at a parallel coordinate plot and click on show the data, which is the default, and so you can see here what's going on average. This is represented down here. You can actually add that in if you want on top of each of the lines. So here's the average for the first cluster, here's the average for the second cluster, and we can see market cap for the first cluster is higher, 97.11, versus for the group 2, which is at 14.23, and we see there's a lot less variation here than there is over here. So that might be an indication that maybe 2 groups is not the best thing to do here. There's a lot of variability within each of the clusters compared to between the clusters. That's something that we want to take into account. And so in order to look at that further, if we come over here and click Save Cluster Formula, that is going to write the cluster to the original data set. So you come over here and say, here is the cluster formula. Now we can use this in order to look at the data using Graph Builder. We actually need to save not just the cluster formulas, but also the clusters. And when the difference here is when you save the clusters, you get not just the clusters, but you also get the distances. So here we've got the cluster formula, we put that in, and now we've got the cluster, which it should be the same as the cluster formula, and now we've also got the distance. And so now we can go to the Graph Builder, come over here to Graph Builder, and we want to put all of these qualitative variables in here. Actually, it's not those variables that we want to put in, but we want to put the distance as our y variable, and then we want to look at that as, let's put cluster down here as x, and then we'll also put cluster up here as an overlay. And then we want to look at this in terms of a box plot. And so the question is, do we have good separation? And the answer is, looks like we've got fairly good separation. The distance within the first cluster is small. The distance within the second cluster is a little bit bigger. And this kind of looks like what you would see with analysis of variance. The question then becomes, what about the difference between, or the distance between these two clusters? And maybe the jury's out on this one. It doesn't look like they're that separated that well. But according to the CCC that we looked at already, this would be the best of these things. Part C of this question asks whether there's a pattern in the clusters with respect to the qualitative variables. So what are the qualitative variables that we have here? Those are median recommendation, location, and exchange. And so let's put location over here, and we want to put cluster down here, and we want to view this as a mosaic. And so this says cluster 1 is mostly US firms, then there's UK and Switzerland. And cluster 2 says about half US firms, and then a single, or I guess a few from all of the other ones except for there's no Switzerland. Okay, so is there a story there? Possibly. It's not really that strong of a story here in this instance. So let's look at the other qualitative variables. So we took the location out and put median recommendation in here. And again, is there a story? Group cluster 1 says about half of them are hold, and the others are moderate buy and moderate sell. And cluster number 2 says about a quarter of them are hold, closer to a half or moderate buy. And again, no real distinguishing difference between these two based on median recommendation. Finally, let's look at exchange and see how these things, or where these things are traded, if there's something that comes up there. So we'll pull out the median recommendation, put exchange in here, and it says cluster 1 is entirely New York Stock Exchange. But again, not that much information here because cluster 2 is almost entirely New York Stock Exchange as well. So we could do the same sort of analysis instead of with 2 or 2 clusters, we could do it with 3 or 4, and that might paint a better picture or help us come up with better names for these clusters. So we would just look at all this output and say cluster 1 looks like New York Stock Exchange, high price to earnings ratio or high market cap, low price to earnings ratio, and so forth. And we there have then kind of categorized these observations according to where they fit in these clusters. And so part E says, how do your results help equities analysts achieve their objective? Well, using this clustering analysis, we can say things about how to develop a balanced portfolio. We don't want all of our assets to be in the same cluster necessarily. If we want to spread things out, we'll be able to look at the different input variables and decide where future companies might lie. This can help us understand the structure in the industry, and that can also be very useful for identifying competitors. So that's all I've got for this question and for this week. We will see you in the next video, whenever that may be. Send me an email if you have any questions.